the article that we published, and there's more data that's been coming out, and it's also been linked as an addendum to this, is that number one, we found that you needed around 1.5 joules of UVC on each side of the mask. And so the point of the article was that's the dose that was used in other studies to do a couple of things. One, it was the dose that killed the viral particles in a lab. It was the dose that killed viral particles on a actual mask. And it's also a dose that did not disrupt the structure of the mask. And so when you have an N95 respirator, you want to make sure it's going to work after you decontaminate it. And obviously, we would never want to do this. Normally we have fresh personal protective equipment at all times, but this moment in time in our nation's history, we don't. And so, like in Detroit right now, we're dealing with it all the time, where we keep being told that we're going to have another supply. We don't, and so we have to repurpose that. So we got the dose down based upon the data, and then we started doing studies with actual masks to see what would happen. And so we worked with our infection control people at Henry Ford Hospital, and our team was able to show that you could maintain the integrity based on a fit test. So we irradiated it. We brought in our phototherapy nurses. Angela Miller, our research coordinator, helped us with this, and our fellows, Dr. Narla and Dr. Lyons and Dr. Torres and Dr. Lim and Dr. Ozag, our chairs, all worked together to try to get this process down. And so we irradiated the mass, and then we noticed that there was an oxidized ozone type odor, and we measured ozone layers. They were not high. But then we also noted this oxidized odor, so we had the people wait 10 minutes before they put it back on, and that seemed to work. And then we did fit testing on them. And fit testing is a technique to make sure the mask is actually blocking all the small particles. And it's where you are exposed to a strong odor, and then the minute you can pick up that odor or that taste, then you know the mask is failing. So we did multiple cycles of UV radiation, and then we were able to find that the mask was able to tolerate, in the most recent addendum to this article, can tolerate up to 29 cycles, the 1860 3M mask. The 9210 could tolerate at least 2, and then it failed, not because the mask failed, but we just didn't have time to do more studies. But then we had multiple masks that we have submitted as a letter to the JAD to supplement the paper. We studied multiple masks, and multiple masks could only tolerate 1 or 2 cycles. So what we've done is we have a manual attached to the article that I hope people will access. Is on the Mendeley platform of the Elsevier Journal of the American Academy of Dermatology. So it links over to that. Please take a look at that manual, because it tells you which mask will work for multiple cycles of radiation and which mask will not work. We also mapped out safety for the operator. So we put in some time, we documented the fact that the UVC is coming out of the entrance. So you have to take about 3 steps back, and then you should be protected from that. And we're also working on other ways to protect the operator. But again, there's a 30-second lockout period. The device goes on, and then the operator won't have a burn or any problems with that. We also did modeling on the actual mask to make sure the whole area got enough of the light dose, and that will be coming out in the next few months. Well, I think for dermatologists, we want to support in the best way that we can, and we found this to be a very helpful format. We have worked with the FDA to hopefully get approval for this particular device, but we did use this in an emergency use fashion, and we've treated well over 1,200 masks now in our hospital system. And just the emotions and the assurance that at the very best, we've been able to do the basic research to show that this device can work. We work with a manufacturer from concept to actual deployment in about 2.5 to 3 weeks. And science doesn't move that quickly, but hopefully our frontline knows that we did what we could, and we can offer that support. And our phototherapy nurses are actually running the devices. So after Dr. Ozag, our chairman, or myself goes in, we train the staff on it. We explain what UVA, UVB is. We explain how UVC is different. And then we show them how to use the device. And then people are reassured. And there's a clean custodian process that we've established with our phototherapy nurses. And every device is labeled with love and support from the Department of Dermatology at Henry Ford Hospital. It just reminds people that it's not just them on the front lines. Every part of medicine, it's every part of society. And these are a way, an expression of dermatology doing its share to support our front line and help care for our society during a very difficult time.